Um, 184.
Again, how does this happen to me?
It happens to me too. It's really stupid.
Okay. Well, good. It makes me feel better. Yeah, when I click on, I guess I got to start from scratch again, huh? It is Common Core High School, right?
Yeah.
And then it's the Algebra 2. And now it gives me that. It's almost like if my browser was set to be bigger, it doesn't show it. I think that's what happened. Yeah, I have my browser set on like 200%. And what happens is this GIF covers up that go to the page number. That's what's going on. What was the page number again? 185?
184.
180. Well, at least now I understand it. And it's because every time it happens to me, I have my page size set bigger. Sure, as soon as I say something, it doesn't go to the page. What the heck? Let me get back to 100%. Okay, now let's try the thing again. Common Core High School. Go. Algebra 2. Go. Page 184. Go. What did I do wrong?
I don't know.
Why don't you pull it up on your screen and you can verbalize problems to me.
Okay.
I don't know why it's not coming up on my screen. You're seeing what I'm doing, right? Does it look like I'm doing everything right? I wonder.
Yeah.
Hold on, before you go there, we can both be there in the same time, right? Let me
Yes.
try one more time, starting from a fresh screen and a screen that is sized properly. Is it something about page 184 it's not liking?
No, I was able to get onto it yesterday.
There we go. I got it. Okay, now I can resize it. Let's see. How do I want to resize this? Not up and down. Yeah, I guess the only way I can zoom in is this way. Boy, that's really bizarre. In other words, this is the only way I can zoom in, and if I zoom in before I get to this page, I don't get it. What problems are we starting on?
27 through 29.
Okay. Let me blow that up one more. There. You should be able to read that. If you can't, you may have to look at. You're good. I think. Can you read it?
Yeah.
Okay. So let's talk about factoring cubics. They've probably, my guess is they've only taught you one way to factor a cubic. Correct?
Um,
All of these problems use the only way you've been taught.
yes.
27 through 30, the answer is yes. They're factorable only because you can group them.
Yeah.
That's the only reason. If on 27 I make that 32 a 31, I cannot factor it by grouping. What you need to be able to factor it by grouping is you need the ratio of these first two coefficients, which is minus 1/8, to be equal to the ratio of the last two coefficients, which is also minus 1/8. See that?
Yeah.
Okay. Since they're the same, you can group them. They have
Okay.
to be the same. Now, grouping is a little more complicated when it's a negative sign in front of the x term, because I can't just do this. I change the expression if I do that.
Okay.
If this was a positive sign instead of a subtraction, I could do this, and I would have no problem. But notice that if I want to group the x cubed and the x squared together, okay, I'll do that. But if I want to maintain that minus sign, what has to go in these parentheses for the other two terms?
Uh,
Kind of have to be able to work backwards. What am I going to write in here so that it's exactly the same as that entire expression?
4x plus 32.
Well, if I do that, now remove the parentheses and tell me if you have the same thing.
It's negative 4x minus 32.
Well, you got the 4x correct.
Oh.
But it's minus 32.
Minus 32.
In other words, when I now remove the parentheses, I better have what I started with. And I do. When I remove, you can always remove the first set of parentheses without changing anything. But the second set, if it follows a negative sign, you got to be very careful if it follows subtraction. Because this sign is always different than the one you're looking at.
Okay.
Okay? So that's a pitfall, but you'll actually catch it. If you don't notice it the first time around, you will catch it, and I'll show you why. What's the next step?
Greatest common factor.
Good. For the first set of parentheses, what is it?
X squared.
Give me the rest of it.
So that's x minus 8.
And over here.
Then take out a 4. So that gives you x minus 8.
Now, if you've done it properly, your x minus 8s will agree. If you've done it incorrectly, this will say x plus 8. And that should be your alert. That should tell you I've made a mistake. Because what's the next thing we're going to factor out?
I don't know.
It's a little unusual. You don't normally factor out binomial terms, but we're going to. I can factor that out. That x minus 8 is common to both terms, correct?
Yeah.
So I can factor it out. Now what do I have left? And the way you figure out what you have left is you divide both terms by that common factor. So what do you have left? What's that equal to?
X I don't know.
Now, look and make sure you see exactly what I did here. I'm looking at an x minus 8 there, and I'm looking at an x minus 8 there. I can therefore factor out the x minus 8. And what do I have left? Well, if I divide this term by x minus 8, I got x squared. And if I divide this term by x minus 8, I get minus 4. Okay?
Okay.
Now, it says fully factor it. Factor the polynomial completely. Well, I got one linear factor, x minus 8. What's x squared minus 4 factor into?
X, hold on, yeah, x squared.
No. Factors into two linear factors.
Oh, x and 2.
X minus 2 times x plus 2. Difference of perfect squares. In other words,
So,
when you're looking to factor, there is a checklist. First thing you search for is greatest common factor. There was none here. The next thing you look for is dose, difference of perfect squares. This was difference of perfect squares. And it always factors in to the square root of the first term minus the square root of the second term times its conjugate. It's as simple as that. In other words, that's the first term you want to come up with. You don't even have to do any work on the second term. It's got to be the conjugate, x plus 2. Now I've got all three terms multiplied together. We're done. Factor it completely. It didn't say solve for the zeros. It just said factor it. And in fact, you'll notice that 27 is not an equation. It is an expression. So
okay.
I'm not solving for x. I'm merely trying to make that cubic be the product of three linear terms. And I've got it down to that now. So what I have circled is the answer. This
Okay.
you lose points if you gave that as the answer, because you haven't factored it completely. Okay?
All right.
All right. That's the way to handle cubics. Let's at least do a second one. In fact, let's keep doing these until you can do it all on your own completely.
Okay. Yeah, I started out not
Tell me
really.
how to rewrite. Well, first of all, let's examine whether it's going to lend itself to grouping. What do I have to know? Remember, it's the ratio of the first two coefficients has to be the same as the ratio of the last two coefficients. So what's the ratio of
Okay.
the first two coefficients?
4 or 2/4 or 1/2.
Well, what's the coefficient of z cubed? Coefficient is 1. What's the coefficient of z squared?
Oh, right. Oh, I was looking at the wrong one. 5.
Minus.
Negative. Sorry.
And what are the coefficients of the other two? What is that ratio?
-9/45.
Same ratio. They're both -1/5. That merely tells me that it's going to work. My grouping method is going to work. Now, rewrite it.
Okay, so it's z to the third minus 5z squared, and then
Parentheses around it. That's what
yeah,
grouping means, is we're grouping one set. We're grouping the z cubed and the z squared, and we're going to group the z and the constant.
right.
Now, you
So
always
then,
have to use that sign right there.
so that's minus
Okay, so what's the rest of it?
9z minus 45.
Okay. Next step.
So then greatest common factors. So for the first one, it's z squared. So that gets you z minus 5. And then for the other one, it's 9. So That gets you z, also z minus 5.
Okay. Good. We got the same two binomial terms. Now what?
So it's
Now, like my to learn math, that's all. Is she or me? Dog. So what's the greatest common factor?
z minus 5.
Okay, good. No, that's true. It happens to be a binomial. It's not a monomial. The problem, this is tough for people because your whole career in math, your greatest common factor has always been monomials. This is really the first time you're introduced to factoring out a binomial. What's left?
Z squared minus 9.
And factor that.
So that's z minus 9 times z plus 9.
You got to take the square root of each term. It's z minus 3.
Oh, so 3, z plus 3.
Right. In other words, this is the square root of z squared, and this is the square root of 9. Always, whenever you're dealing with difference of perfect squares. So that's our answer. Z minus 5 times z minus 3 times z plus 3. And we factored it. Again, it's an expression. We don't have to solve it. Just have to factor.
All right.
All right. I say that I think you've learned both of those. And in fact, the next two also have that negative sign. So not any of these four have a positive sign, which makes it a little easier. You can't really go wrong if that's a positive sign. But it's really easy to make a mistake if it's a negative sign. So let me look at the rest of your homework and see if we can find something a little more interesting. We were supposed to do 27 through 29 and 39 through 43. Let's try 39 through 40. Okay. So here they give you a cubic, which obviously is not groupable, right? 39? Which 2/5 is not the same as 37/60. So if they wanted us to factor it, we wouldn't be able to do it. But that's not really what they're wanting to do. They give us one solution. They give us one factor. Okay? Well, if I divide this cubic by this linear, I get a quadratic. So then I'll have a linear times a quadratic, and I can factor the quadratic and turn it into 3 linear factors.
Okay.
Okay, so that's going to be the goal. Now, the first step, we got to divide this cubic by x minus 4. Should we do it with synthetic? Synthetic is always easier once you learn how to do it.
Yeah, synthetic's really easy.
What's in the box?
So,
it's not x minus 4. It is 4. It is whatever 0 that would produce. In other words, if you set that equal to 0, you get x equal 4. So if I'm going to divide it synthetically, I'm dividing by the 0, which is 4. Goes across the top.
2, 5, 0.
No?
Oh, oops. Negative 37 then. And then negative 60.
Okay. In other words, you need zeros only if you're missing a variable. We're not missing any. We have x cubed, x squared, x, and a number. Okay. You're good with synthetic? Good enough for me to do it?
Yeah.
What's the zero tell us?
The remainder.
Correct. The fact that it's a zero means what?
Oh, that it is factorable.
Well, it means that x minus 4 is one of the factors. If I did not get a zero remainder, if I got 1 or 2 or any other number, then it tells me that x minus 4 is not one of the factors of that cubic. If x minus 4 is a factor, then it must produce a zero remainder. It's called the zero remainder theorem. Okay, so it is a factor. Now let's write all the factors we know over here on the left. One of the factors, x minus 4. What's the other one at this point?
2x squared plus 13x plus 15.
Okay. And you always knock it down by one level. When you divide a cubic by a linear, you end up with a quadratic. If you divide a quartic by a linear, you end up with a cubic. So it's always you're knocking it down 1 degree. Now, this is probably factorable, I'm guessing. Let's give it a shot. We'll see how good you are in these higher degree of difficulty factors. Actually, hold on a minute. I just realized we've answered the problem. It doesn't say factor it all the way down. The only thing it says is the binomial a factor of the polynomial? And we just proved that it was. All we have to do.
Okay.
The only thing you have to do to prove it is to get that zero remainder. Let's do one more of these. Let's do 40. So set me up. How do I tell if x plus 7 is a linear factor of that cubic?
Okay. So in the box is negative 7. And then, so the numbers are 3, negative 28, 29, and then 140.
Okay, this time I'm going to let you do it because the whole goal is to see if we produce a zero over there. So I'll point and you write. Or you announce. I know you can't see where I'm pointing, but you know where I'm pointing.
So 3, negative 21. So that's negative 49.
Can you tell yet whether or not this is going to work? You don't always have to go to the end to know you're not going to get a zero over there. I don't have to bring out my calculator. I know this number is about 300. Now, if I add those together, I get 329. If I multiply it by 7, there's no way I'm getting minus 140 there. So that tells me that cannot be 0. So no, x plus 7 is not a factor of that quadratic.
All right.
So sometimes you have to do the arithmetic out, but if you can spot it early, in other words, I knew that multiplying 7 times 49 was going to give me a huge number. And then I've got another huge number, and then 7 times that huge number, there's no way I get back to negative 140.
Okay.
So sometimes you don't have to go all the way to the end to figure out that it's not a factor. You do have to go all the way to the end to figure out that it is a factor. Through 43. Now, you good on these? Shall we go on?
45. Oh, yeah, those are good.
Okay. Here, let me look at how many we got here. Yeah, we got a lot. 45 through 54, is that it?
Yeah.
Okay. So let's have a look at 45 through 50. Whoops. What's that top say? I covered it up. Show the binomial as a factor of the polynomial, then factor the polynomial completely. Okay, this is like the previous problem, except the previous problem said, is it a factor, and an end right there. This one, we have to prove that it's a factor, and it's going to be, I can guarantee it. And then we have to factor the resultant quadratic. So, tell me what to do on 45.
So it's -4 in the box.
Across the top.
1, -1, -20. And then 0? Or?
Yes, I believe. We'll find out. But yes, I think you have to. In other words, what we're missing is the x to the 0th term, right?
Right.
So we got to put a 0 in there. In other words, x to the 0 is 1, so it would normally be a constant, but we won't be able to tell if we get a 0 right there without putting that dummy 0 in. So bring the 1 down, multiply, add, multiply, add, multiply. Now that would indicate that we're done.
Yeah.
That's not where you got to find the 0. You got to find the 0 over here. But now -4 times 0 is 0, and 0 plus 0 is 0. So it is a factor. So now where are we at? What are my two factors that I know at this point?
X plus 4.
You know that's a quadratic.
Right, so that's x squared minus 5x. Yeah.
Now factor that.
So x plus 4 times x
All you did was take a greatest common factor out. What do you got left when you take out an x?
x minus 5.
Okay. And there it is, fully factored. And factor the polynomial completely. We've done it. Still doesn't ask to solve for the zeros, so that's the answer. Okay.
Okay.
have you do one more. That was a little sketchy. Ooh, 47 is going to be a tougher one still. Tell me how to do 47. This is a quartic.
The number in the box is 6. Then the numbers are 1, -6, 0, -8, and 48.
Now we know we're going to get a 0. So I'll do it quick. So now what?
So then the factors are x -6, and then x to the third -8.
Exactly. Now, you know the formula for difference of perfect cubes.
Yes.
Okay. Factor x cubed -8.
So,
in other words, you might look at that and say -2. Or rather, +2. Right?
yeah.
And that might look like the only factor is 2. But there are others. And the only way you find the others is by using that formula for the difference of perfect cubes. So what's the first linear term?
X -2.
What's the second quadratic term?
X squared. Is it? I think it's minus.
What was the opposite sign?
Plus.
Whatever your linear term has.
Okay, so plus 8x.
No. Oh, excuse me. No, it's 2ab. It's ab.
So 2x.
2x. That's what ab. A is x. B is 2.
Okay.
B is -2. B is 2. Because we're dealing with the difference of perfect cubes. So my b is 2. And then the third term here?
4.
Now, factor completely. This over here is not a reducible quadratic unless we want to introduce imaginary numbers.
Okay.
And the way this usually works, I can't guarantee that this is what your teacher wants. If you have answers and can look them up, we'll know. But in my book of math, you reduce any polynomial to its linear factors and irreducible quadratics. You don't go down further than irreducible quadratics because this will give us imaginary solutions. So I'll have an x minus some number of I and then an x minus something plus I. There's no need to really go into the imaginary realm. But I don't know, from these instructions, it does say factor completely. So I would have to apply the quadratic formula to that quadratic to see what its two imaginary solutions are. It's just that I don't know if he wants you to do it. Do you have answers anywhere on these?
No.
Okay, so we're not going to be able to figure it out. Well, just make sure you know how to do it either way. In other words, that's the answer with linear factors and irreducible quadratics. If I want to go further, well, then I got to factor this. Let's just talk about doing it in case he wants you to do it. First of all, I know that that does not have real solutions. Because if I look at the discriminant, b squared minus 4ac, it's negative. So I know it's imaginary solutions. Let's figure out what they are. Use the quadratic formula.
So
Tell me the quadratic formula first, the general.
So opposite b, plus or minus the square root of b minus 4ac.
B squared minus 4ac.
Oh, b squared minus 4ac.
All over 2a.
Yeah.
So plug it in.
So negative 2 plus or minus 2.
Hold on. Plus or minus the square root of 2 squared, which is 4, minus 4 times 1 times 4.
So that's just 4. That's not obvious.
No, hold on. That's 4 minus 16.
Oh.
So it's minus 2 plus or minus square root of minus 16 is what? Excuse me, it's the square root of minus 12. 4 minus 16 is minus 12. So it's the square root of minus 12. Simplify the square root of minus 12. What's the square root of minus 12 equal to? And in this case, you need to simplify it. I'll show you why. If the negative sign gives you problems, then do this always as the first step.
Okay.
And because that becomes I. Now simplify square root of positive 12.
6.
4 times square root of 3. So that's 2 root 3. So this becomes 2 root 3 I. We're still dividing it all by 2. That's why it was so important for me to simplify root 12, because I can eliminate all these 2's. And now my answer is minus 1. Doesn't go away, but it becomes 1 plus or minus root 3i. Now, that's my answers for that irreducible quadratic. How do I write that? In other words, instead of x squared, instead of this over here, I got to write it as the product of two imaginary numbers. What are they?
-1 and then square root of 3.
No. When you solve for x, the factor is x minus that number. Just like when we knew that 6 was a 0, then the factor is x minus 6. If we knew that 2 was a 0, then the factor is x minus 2. Well, here are our zeros. So it's x minus the first one. I got to use double paren. And the second one is x minus the other answer, which is But be careful here. The other answer is minus 1 minus root 3I.
All right.
So what I have in the rectangle is the full, complete answer. Now, these can be simplified a little bit. In other words, if I remove the inside parentheses, I've got x plus 1 minus root 3I. And if I remove this parentheses on the inside, I get x plus 1 plus root 3I. So this is a better way to express it. At the very bottom, I'm out of room, so I can't even go any further, but if I want to multiply all four factors together, if you multiplied all four of these together, you'd get your original cubic or quartic.
Okay.
Okay. And like I said, I don't know that they necessarily want you to break it down to that. Most math books I've ever studied say when you're factoring a polynomial completely, factor it down to its linear factors and irreducible quadratics. What an irreducible quadratic is that one that only has imaginary solutions. So personally, I wouldn't do this last step. I would leave it as x squared plus 2x plus 4.
Okay.
And the instructions don't actually say take it down to all its linear factors. They just say factor it completely. So they actually leave it open to have one of the factors be a quadratic.
Okay.
There's just not much advantage in taking it all the way down to the imaginary factors. So you generally leave it as a quadratic if it's going to produce imaginary. Let's see, that was 47, right?
Yeah.
Okay, let's do 48.
So the number.
Start a little bit higher so I can go top to bottom. What goes in the box?
So -4.
Across the top.
1, 4, 0, -64, and then -256.
Save time. So it definitely is a factor. Now tell me where we're at this point.
So the factors are x plus 4 and x to the third.
You always knock it down by exactly 1. So we started with x to the 4th. It's got to be x to the 3rd.
Okay, and then -64.
Okay. Again, this looks like, what's that called? Difference of perfect cubes. Dope C.
Okay.
Factor it.
So x.
Whenever you see a cubic like this, and if you didn't know what to do next, well, no, you got to factor this thing. and we just happens to be a perfect cubic difference of perfect cubes. So factor it based on your knowledge of how to factor a difference of perfect cubes.
Okay. So x minus
Cube root is 64. Always going to be a low number. It's either 1, 2, 3, or 4.
4.
It's the other side. The rest of
it. X squared plus
opposite, whatever this sign was, this is opposite of.
So plus 6 or 4x plus 16.
Now, this is almost always imaginary solutions only. If you, and a quick way to determine that, I'm not sure if it is 100% of the time or not, but this is what you have to evaluate. If that's a positive number, it's real solutions, and we would want to keep going. But if that's a negative number, then it's imaginary solutions, and we have an irreducible quadratic that we would just leave. So is that positive or negative?
Positive.
Well, plug it in. What's b squared?
16 minus 4 times 1 times 16.
Is that a positive number or a negative number?
Negative.
Okay. That means that's an irreducible quadratic. That means that's as far as I'm going. That's your answer. And this time I'm relatively certain this is acceptable because it just says factor the polynomial completely. It doesn't say all the way down to its imaginary solution. I'm betting if you did have answers in the back of the book, this would be what it is.
Okay.
Let's see. That was
48.
Yeah. There's something pretty interesting about 48. Notice. I could group that. I'm looking at a 1 to 4 ratio. And negative 64 and 256 is a 1 to 4 ratio. So just curious what would happen if we tried to group it. I think we get the same answer. Let's just give it a quick look, not to waste time, but I don't think this is wasting time. In other words, I happen to notice that that can be grouped. So it's x to the 4th plus 4x to the 3rd minus 64x plus 256. Okay, same quartic.
Right.
Take a greatest common factor out. We get x cubed times x plus 4 minus 64 times x minus, or x plus 4. Now I can factor out the x plus 4, leaving x cubed minus 64. And now I can factor that into using the same difference of perfect cubes. So I actually could have done it, and notice that I came up with this independent of them. They told us that x plus 4 was a factor. I didn't need that information. Because they gave us a quartic that could be grouped, I was able to group it and solve for x plus 4 as a linear factor. Still got to finish the problem. In other words, I still got to use difference of perfect cubes to do x cubed minus 64, but I get the same answer. I get x plus 4 times x minus 4 times whatever that irreducible quadratic is.
All right.
That's something I actually never knew. I've never actually factored a quartic by grouping. It's the first one I've seen where I noticed you could even do it. All right, let's see. We've got 5 minutes. Let's see if there's anything more interesting on your documents. What's the next question? We only have time for one more. You have your page in front of you?
Yes.
What's the next question after this series?
That's it.
Oh. So you were only supposed to go to what? Which one? 50 or 48?
No. Oh, the next one. Oh, sorry. Yeah, it's 49.
Okay, let's do 49 and we'll be done.
All right.
Since they've given us one of the factors, then we know that if we divide that cubic by that factor, we're going to have a linear factor and a quadratic. So that's clearly the way to go. I'm not going to look for any other things like grouping here. Let's just do the synthetic division. What goes across the top?
1, 0, 0. Oh, wait, no.
Just 1, 0.
Negative 37. Then 84.
It's the other factor.
So, x to the, x squared minus 7x plus 12.
Notice that this factors. So you don't always get an irreducible quadratic. Sometimes you get a quadratic that can be factored.
Great.
There you go.
All right.
Mitris, I will talk to you on Thursday.
Yeah.
We'll do more.
Okay.
All right.
All right. Thanks.